So here we have shown the concurrent force system, and we have to find out what will be the resultant of this particular system. So here we are having various forces. So this 200 Newton force is the pull type of the force acting on this particular point. This 300 Newton force is the push type of the force. Then this 500 Newton force is the pull type of the force, and 400 Newton force is the push type of the force. Now the space between these particular forces is divided by using the Bow's notation. So this A, B, C and D, these are known as the Bow's notation. According to the Bow's notation, we can say that this AB is representing this force of 200 Newton, which is of pull type. Similarly, BC is representing this 300 Newton force, which is of push type. Then this CD represent this 500 Newton force, which is of pull type. And finally, this DA represents this 400 Newton force, which is of push type. Now let us try to understand how to find out the resultant of this particular system. Now we'll draw this particular force system. Now as we have already seen, this is the space diagram and the angle between these two forces. So angle between these two forces is 50 degree and angle between these two forces is 70 degree. Now A, B, C, D are these Bow's notations as we have seen already. Now we'll start with this particular AB. So AB is representing this 200 Newton force. So we'll take some suitable force diagram scale or vector diagram scale. Suppose we'll take 1 centimeter is equal to 100 Newton. Then we can say that this 200 divided by 100, that is 2 centimeter, will be the length by which we will be representing this particular force. Similarly, BC is representing this 300 Newton force, and as we have selected a scale of 1 centimeter is equal to 100 Newton, therefore 300 divided by 100, that is 3 centimeter, will be the length by which we will be representing this particular force. Similarly, this CD will be representing this 500 Newton force, that is 5 centimeter, and DA will be representing this 400 Newton force, that is 4 centimeter by scale. So let us start with this particular diagram, that is the force diagram or vector diagram. So the first force is 200 and that is represented by this AB by 2 centimeter. So we'll draw this 2 centimeter length. Then so the first force that we have drawn is of 2 centimeter length parallel to this particular 200 Newton force. The second force is BC. Draw a line parallel to this 300 Newton force, that is 3 centimeter by scale. The next force will be this particular force. So draw a line parallel to this 500 Newton force by 5 centimeter. So this length will be 5 centimeter. Then from this point, draw a line parallel to this 400 Newton force by 4 centimeter. So once again try to understand this. So this 200 Newton force is represented by AB. So A to B, that vector is 2 centimeter. Then BC, that vector is representing this 300 Newton force. So it is 3 centimeter in the downward direction. Then this CD vector will be parallel to this particular, that is 500 Newton force and by 5 centimeter. And then from this to this particular vector is of 400 divided by 100, that is 4 centimeter length. Then the closing side of this particular polygon will be the resultant of the given particular force system. So A, B, then C, D and A dash. Now give the arrows, appropriate arrows to this particular diagram. Then this is the closing side, and this A dash will be the resultant of the given particular force system graphically. Now, as you can see over here, we are having this particular length A dash we have measured, and it is 5.3 multiplied by the scale. The scale that we have chosen is 1 centimeter is equal to 100 Newton. So 5.3 into 100, that is 530 Newton, and it is making an angle of 54.2 degree with the positive x-axis. So in this way, we can calculate the resultant in magnitude and direction of this particular coplanar concurrent force